Okay, in today's class we'll be looking at permutation of digits. Okay, look at this question. How many 4-digit numbers can be formed with 1, 2, 3 down to 9 if number 1, repetitions are allowed, number 2, repetitions are not allowed, number 3, the last digit must be even, and repetitions are not allowed. Okay, so let's look at the solution as fast as possible. For the first question, repetitions are allowed. How many 4-digit numbers can be formed with this? So it means my n is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. And in this case, my r, which is number of arrangements, is what? Is 4. Now, the first question says repetitions are allowed. So it means out of these 9 digits, if repetition is allowed, the first arrangement will be 9. That's first arrangement. Now, if the first arrangement is 9 and repetitions are allowed, it means it will reset back to the total number of items I have on board, which is still 9. So 9 again for second, 9 again for third, and 9 again for what? Fourth. And that's what this is it. So how will I now get my answer in this case? This now becomes 9 times 9 times 9 times 9, and that's 81 times 81. So after multiplying, you get your answer. So that's for that. Number 2, if repetitions are not allowed, it means my first arrangement, n1 in that case, then also first arrangement will be what? Will be 9. Second arrangement will be what? Will be 8. Third arrangement, that's n3, will be what? 7. And fourth arrangement will be what? It will be 6. In this case, I'm going to have it as what? 9 times 8 times 7 times 6, or 9 permutation 4. 9, which is the total permutation, we have 4 arrangements. It is without repetition relatively. So it is without repetition. So, and this now becomes what? 9 factorial over 9 minus 4 is 5 factorial. So, and that is still 9 times 8 times 7 times 6. So I'm multiplying. Whatever I get as your answer would be the answer relatively. So 9 times 6 here is 54. 8 times 7 is 7 times 8. 7 times 7, 49. 7 times 8, 56. So on multiplying, you get your answer then. So that's for this about this. The number 3 question. What do we have? They said the last digit must be even and repetitions are not allowed. The last digit must be even. Now looking at our total number of items, which is 1 to 9. The last digit must be even. Now, amongst these 9 numbers, we have how many even numbers there? 1, 2, 3, 4. That is, even numbers present in my series is what? Is 4. That's 2, 4, 6, 8. Now, as I said, the last digit must be even in this total number. Now, since we have more than one even number, any of these can be the last even number. So, how do I now solve in this case then? How I'll solve is relatively simple. To get the last digit that must be even and repetition not allowed means I have to first identify all the even numbers. Then let me now start filling them one after the other then. So, now once I fill in the last even number, I can start with any of them though. 4, 5, 6, 7, 8, 9. Okay, so if I fill in this last even number, it means I will have how many items left? My new n now, let me call n star. N star now. N star now becomes what? 1, 2, 3, 4, 5, 6, 7, 8. It now becomes 8. Now if n star becomes 8, it means I can pick from this. I'm to find how many 4-digit numbers can be formed with this if the last digit must be even and repetitions are not allowed. Now if the last digit is even, this is the last digit that is even. Now I'm starting with 8. So if this is even, how many do we have left? We have 8 left. It means my n star 1 now can come from what? These 8 selections. Now if my last digit is even, this is the second one I'm also testing. Assuming 6 was my last digit now, how many do we have left? It means for my second selection, I can pick from how many? 1, 2, 3, 4, 5, 6, 7. Pick from 7. Now, if my last digit is even again, this is this. What do I have left? N star 3 can be selected from how many? That's 6 automatically. Now, what do we have left? 1, 2, 3, 5, 7, 9. This is all we have left relatively. So, how do we now solve? Very simple. This is the last digit now, which is already even. So, I don't need to cancel out here again, because after removing all the even digits, I have 2 remaining. If I start from 2, I might have 4 remaining. So, we can start from anywhere relatively. So, how do I now solve? Solving now becomes what? 8 times 7 times 6 times 4. Now, this 4 represents these 4 digits that can be formed from this sequence of number if the last digit is even. If the last digit is even, we start from 8, we got 8 remaining, we go to 6, we went to 6, we had 7 remaining, we went to 4, we had 6 remaining. So relatively we can see that we have only one last digit here, which is even, and that is 2 in my case. So that's going to be 4 times these 3, or you can say this as what? My new n star, that becomes n star permutation r star now. Now my r star represents these 3 of them. This is my r star. Okay, hope you understand. So that's n star permutation r star, times 4 still. So, and that's what? 4 times what? 8 permutation 3. And you get your answer as 4 times 8 minus 3 is what? 8 minus 3 is 5. So that's 8 times 7 times 6, which is still the same thing as what I have up here. That's the solution to this question.